Cool. So today we're here to talk about ECMAScript 6, which is the new version of JavaScript. So it's a really exciting time for the JavaScript community. As you know, JavaScript is gaining importance. Lots of single-page applications, lots of frameworks, and now finally we've got the release of a new version of the language, which has got lots of new features and things that we've been waiting for a while. So first of all, who am I? I'm Sebastiano Armeli. I work for Spotify, which is a music streaming service. It's not here in Russia, but it's quite popular in the US and in Europe, in Australia. I work there. I work in New York City. I'm also the author of a book on MVC pattern applies to JavaScript. If you're interested in the topic on model view controller. So you can apply the model view controller pattern not only on the server side, but also on the client side. Anyway, the topic for today is ES6. So we're going to go through the different features of the language, and we're going to do a bit of comparison with some existing languages and like how they implement the same features as well. But before digging into those features, let's look at a bit of history of the language. As you know, JavaScript was invented by Brendan Eich in 1995 in May. The initial name was Mocha, then got renamed LiveScript, and then got renamed in December JavaScript. In 1996, Microsoft had a similar version called JavaScript. They didn't want to use the name JavaScript because Java at the time was part of Sun Microsystem. And then in 1997, we've got the release of the standardization called ECMA 262, edition 1. In 1998, we've got the second edition, in 1999, the third edition. So it seems like every year we've got the new edition, everything seems to work fine. In 2000, we got the starting of the edition 4. Edition 4 had lots of changes, lots of new features. They caused lots of discussion in the community because there were lots of blog posts saying that the edition 4 was breaking the web. So what happened in 2004, this edition got abandoned. And in 2005, people, especially in Adobe, Mozilla, and Google, started again working on this spec. But Microsoft and Yahoo didn't agree on those features, so they started a different version called 3.1 with small adjustments. So there was a bit of a disagreement in the community. And what happened in 2008, we've got this meeting in Oslo in July where Google, Adobe, Mozilla, Yahoo, Microsoft, they got together. And in the end, decided to release 3.1 became edition 5, which is the version that we're currently using. And it's been standardized in 2011. And edition 4 basically was split, and part of it divided in different proposals, and those proposals are part of ES Harmony. So ES Harmony because we're supposed to bring harmony in the community. So at the moment, the features for ES6 is basically the 6th version, and it's part of the ES Harmony set of proposals. The features are pretty much completed. There are just some bugs fixing, and all the browsers are implementing the different features, especially Chrome and Firefox have been implementing them pretty well. And in next year, in June, we should have the release of the edition 6. So a bit of a terminology that probably you hear when you hear people talking about ES6. So first of all, ECMA is the organization behind the standard. ECMA 262 is the name of the standard. So it's the name of the standard, and JavaScript is an implementation of it. TC39 is the committee that basically decides the proposals. So each proposal, actually, it's there are like 1 or 2 people called champions that are in charge of each proposal, and all those champions are basically part of TC39. ES Next is basically the pointer of the next version. So currently the pointer points to ES6, but next year the ES next will be ES7. And ES7 is the version after ES6. There are already proposals in ES7, like object.observe, so two-way data binding, for example, or async. And ES Discuss is a really nice website where you can look at all the different threads and different discussion happening in the community around ES6 and ES7. So a bit of summary about the topics that we're gonna cover today. So let's start with arrow functions. So fat arrow functions. I guess if you're familiar with CoffeeScript, there's nothing really new. So it's a shortcut for writing functions. So you basically use this operator here instead of using function and return. So pretty much it's just syntax sugar in this case. But the main advantage of using fat arrow function is that this keyword is bound lexically. So that means that the value of this in a fat arrow function is set to the value of this of the outer function. And also those fat arrow functions, they don't have constructors. So basically they are like they're used for anonymous functions. So they don't have they're not constructors, so they don't have the prototype object associated. Other examples on how you can implement fat arrow functions and how they get translated into ES5. So for example, you can use the return keyword. Also, you can return, if you return an object literal, you need to wrap the object literal in parentheses. Otherwise, clearly you're going to have double curly braces. But as I said, the main advantage of using fat arrow functions is the fact that this is bound lexically. So let's look at an example to clarify that. So typically in ES3, so in JavaScript, like that we currently use, for example, when we have an event handler attached to the click event, the trick that we do to use this keyword inside this event handler is associating this to another variable called that or self, right? And so then we can use that inside the handler because of a closure. In ES5, there is the bind function attached to the prototype of a function class. So we can use this keyword inside the event handler, but we need to do this kind of trick using bind, which is nicer than doing var that equal this, but still we need to do something in order to enforce this inside the event handler. In ES6 now we can use fat arrow functions. So that means that this value of this fat arrow function is equal to this of the outer function. So basically it's the object here. So which is really cool because now it comes out of the box. So if you're still wondering about the prototype, the hidden proto-link of a fat arrow function, is still function.prototype. So it's still a function. But it doesn't have the prototype object associated. So we saw that now you can use fat arrow functions, so you don't need to use the function keyword. But there are still cases where you will use the function keyword. So those cases are when you want a constructor. So you still there are cases where you want to have a constructor in JavaScript, which are like classes. Generators, which is really another feature of ES6. It's a really cool feature. I guess it's if you use Python, nothing new here. And then methods in object literal. You're not. It's not necessary to use a function in methods for an object literal. Now we've got the shorthand notation for that, but you can still use it. Now, second topic, scoping, destructing, and parameters. Let's start with scoping. So as you know, in JavaScript, we got like two kinds of context, the global context and the function context. So the lexical environment is determined by like the window, global, or the function. So you don't really have a lexical environment determined by a block. So when I say block, I mean an if statement, a for loop, like other languages. So if you think about Ruby, Python, you basically have variables that are valid only in a block. So now, finally, in JavaScript, we've got the same concept, but you will need to declare variables using let and const keywords, so not using var, as you do at the moment. And also, the variables, since they are now, they have a block scoping, they're not hoisted, like using var. The concept of hoisting, as you know, means that the declaration of the variable goes at the top of the function as the first line of the function. So the compiler basically declares all the variables at the top of the function. So let's look at an example. Currently, if you're using var, what happens is that even if var is defined in a block, so in a block like this if true, the compiler will hoist y at the top of as the first line of the function. So it will be like a var y equal undefined. So if you try to print out y, you will get undefined. And if you try to print y after the block, you will get value because there is no block scoping. Whereas now, if you use let and const, the value of y is enclosed inside the block. So that means if you try to print out y after the block, you'll get an error because it doesn't exist. Const, similar concept, but it's a constant. So it's basically static final kind of variable. So it needs to be initialized and can be redefined. So it's basically a constant. So for example, a use case can be when you require a module on server side, like in Node, you will use a const because you just need to require the files at the top of, like a package at the top of your file once. Destructing arrays. So destructing, that's a thing that, for example, in Clojure, it's really popular. For example, given an array, you can just deassociate the items inside an array and associate the values to variables. So for example, you've got an array, you can simply deassociate those values into two variables. So, and other cool feature, you can also play around with destructing. You can swap values. So for example, as you can see here, you've got x and y, and then you can say y and x. You can swap the values, which is really cool. You can destruct also objects. So if you've got an object literal, you can deassociate the values. So for example, as you can see in this line here, now the W value will be 50 and the H value will be 100. Also, there is a shorthand notation here. So if the name of the property is the same as the name of the variable, you just need to specify the name of the property just once. So you don't need to repeat with, colon, with, which is nice. So yeah, those are really like kind of handy features for breaking down objects and arrays. Other thing about parameters instead. So as you know, in JavaScript at the moment, there isn't a way to define default values. So that typically what we do is basically we do this kind of thing to define a default value. But now you can do, in ES6, you can do basically a signature like this, like you do in Ruby, for example, which is finally is really cool. It saves you lots of time. REST parameters. So this is another concept about parameters in a functions. So as you know, at the moment, often we deal with the keyword arguments, which is like an array-like. And it basically represents all the arguments of a function. But these arguments is not an array. But now, if you use the ... three dot ellipsis notation, you will be able to get the an array. So in this case, this args variable is an array. In fact, you can apply the for each method, which is a method you can use in arrays. It's part of ES5. Actually, not many people know that for each is part of ES5, so you can use it already. Yeah, so for example, as I said, if you pass in A, B, and C to this function, you'll be able to print out the single values because you loop through the array. Another thing about REST parameters is that you can mix it up with positional parameters. So for example, in this case, you've got a positional parameter at the beginning, A, and then you can say all the other parameters are part of the array args. In this case, if you invoke the same function, passing A, B, C, basically A will be associated to the first argument, first parameter, and then B, C will be the rest. So it's really handy. Now, third topic, iteration and generators. Now, this is really important topic, especially generators. So first of all, about iteration. As you know, the classic way of iterating in JavaScript is using for-in loop. For-in loop, though, has got like a few limitations. In fact, if you think about iterating on an array, if you iterate on an array, you will get the indexes of an array. You don't get the values, which is pretty annoying, right? So now we've got this new construct for-of, which will, for an array, will allows us to get the values of the array, for example. But it's applicable to iterables and iterators. Example of iterables are array, maps, and sets, which are maps and sets are new constructs, new collections that we're going to look at later. And iterators are new type of objects that are basically, it's possible to generate them from iterables, so from array sets and maps. But anyway, let's look at examples to clarify those concepts. So as I said just now, you can use the for-of loop, for example, in an array, and you'll be able to get the values of an array instead of the indexes if you use for-in. As I said, iterable are basically like an array is an iterable, but what defines an iterable is the fact that it's got a symbol called iterator. So in ES6, when you see this symbol, these kind of characters means that you're dealing with a symbol. So you've got a symbol called iterator, which returns an iterator. An iterator is an object that has got a method called next, which allows you to iterate on it. It's basically, I mean, it's a feature that you got in Java, in C#. So, for example, if you got an array, say ABC, and you've got methods like entries or keys that allows you to generate iterators. And given an iterator, you can loop through this iterator. So, for example, if I call array.keys and I iterate on this iterator, I will get the indexes of the array. If I call array.entries, I will get the values. So iterator, again, are possible to be generated by iterables. Now, generator is a specific type of iterator. The main thing about generator is the fact that it's not like a typical function that you execute from the top to the bottom, but it's basically something that you can stop the execution and resume it later. So as you know, in JavaScript, JavaScript is multi-threaded. So it doesn't change the nature of JavaScript. So we're still having our single thread. But the fact that now we can invoke a kind of function and we can stop the execution and resume it later is really powerful to manage the control flow. So for example, so first of all, what defines a generator is the star. So you function and star. So when you see this kind of signature, it means you're dealing with a generator. So this kind of signature defines a generator constructor. And then if you invoke this generator constructor, you've got your generator object. Now, as I said before, generator is a type of iterator. So an iterator has got a next method. So you can apply a next method on the generator. So if you apply the next method on the generator, you will be able to get to the first yield value. So what happens is that first time you call next, you basically invoke this kind of constructor, and you get to the first yield. And you will get the expression that you are yielding. In this case, it's A. So the value is A, and also you get the property done that is equal to false, because we haven't finished going through the generator. So second time you call again the generator. I mean, you call the next function on the generator. You start basically from yield. So this generator constructor gets resumed, and we go to the next instruction, which is B. So in fact, the value will be B, and done will be false. And then, but still we're not done because we are here. So third time we call next on the generator. We basically go to the next instruction, which is the compiler basically translates it into return undefined. So we finally can exit this function. So the value will be undefined, and done will be true. So, and we're done with our generator. So that's how basically we can stop and resume the execution. But also, you can pass values out from the generator, but also you can pass values into the generator. So in this example, you can see how the third time you call next on the generator, you can pass in a string, C. So in that case, what happens is that C gets associated to the value that this value, red val in this case, so the value that that yield is defined on. And then, so the third time you call the next function, you will get the return red val, which is C. So it's really nice. You can pass in things with generators as well. But one of the most powerful things about generators is being able to control asynchronous operations. So are you guys familiar with promises? Anyone familiar with promises? Yep, OK. So yeah, OK. So if not many people are familiar with promises, I mean, promises is just a way of dealing with synchronous operations in JavaScript instead of using callbacks. That's a very short explanation. But anyway, the concept here is that you basically can call the next operation, and for example, in this case, and you'll get that getUser function. But that getUser function returns a promise, which holds the asynchronous operation. And then when the promise returns, you can call the generator again and decide what to do. So that's really powerful to manage asynchronous operations, because promises handle asynchronous operations. Fourth topic is collections. So as I mentioned, there are new collections in ES6 in JavaScript. So there are maps, sets, and weak maps. So let's start with sets. So there is nothing really new about sets and maps, because I guess everyone has used it in other languages. So sets are basically a collection with no duplicates. Same deal in JavaScript. You can have different types in a set. So you can have a string or an object in the same collection, which is cool. You've got methods like add, has, or delete, which is really typical for sets. And also you've got a values method, which returns an iterator, which allows you to get the values of a set. So let's look at some example. So for example, you can define a country's variable. So simply doing new set. Then you can add things to this variable. And as you can see here, if I add US, Italy, and US, and I try to print out countries, I will get US and Italy, because we don't have duplicates. That's really simple. Now map. OK, this is a bit off. Yeah, sorry for the slides because they got translated into PowerPoint, and I built them in Keynote, and they got translated in PowerPoint. Anyway, so the map is basically just a pair key value pair. So it's like in other languages. The cool thing about maps is that keys can be objects, so you can have an object as a key. And you've got methods like get has set, so you can put things in a map, you can get things from a map, and also you can iterate through a map using, for example, for each, which is a really nice function. So in for each, you can pass, you can get all the different keys and values and the map itself inside the function, which is nice. So some examples, you can declare a variable, a map using new map. Then you can put stuff in a map. So in Java, you use put method. In JavaScript, you will use a set. And then, as you can see, you can print out a map. You can get things from a map. So you can, the parameter will be the key, and you'll get the value. And you can also delete a specific entry. Now, weak maps, that's kind of interesting. So they're a bit different from standard maps. The main difference is that they are built to avoid memory leaks. The meaning of weak map is that the reference to the key object is held weakly. So first of all, the characteristic of a weak map is that the keys must be object, and the reference to the key is held weakly. That means that basically, so when you use a standard map and your key is an object, if that object gets, for example, set to undefined, the garbage collector is not able to garbage collect the variable because the map holds the reference to the object strongly. In a weak map scenario instead, if you set the value of that object to undefined, the garbage collector is able to garbage collect the object because the reference to the object is held weakly. So that's really important because it can avoid like all sorts of memory leaks that often we got in JavaScript with zombie objects, for example. But for the way the weak maps are implemented internally, we don't have iterator methods applied. Like instead, we've got with maps. So you can, for example, iterate on the entries or on the values of a map because you basically don't keep the state. That's why the reference is held weakly. So an idea of how to use a map and weak maps is, for example, with properties, attributes of an object. So in this way, for example, if down the line, I don't know, your property get set to undefined, that property can get garbage collected. Other topic very interesting is classes, templates, and modules in ES6. So first of all, object literal. Finally, now you can define the hidden prototype of an object literal. So you can it's really important for inheritance and also for better understanding the prototypal inheritance in JavaScript. So it's really visible now how inheritance works in JavaScript. And also, as I said before, a method in object literal can be defined this way, so you don't need the function keyword anymore, which is a nice shortcut. Modules. So at the moment in JavaScript, we've got different ways of building modularity. So as you know, usually we are developing in a client side, you tend to use AMD, which is enables more asynchronous kind of loading, which is more suited to client-side development. Whereas the Node community uses CommonJS, which is more a server-side approach because it's a synchronous loading of modules. With ES6, basically The concept around ES6 is that you'll be able to load modules either synchronously or asynchronously depending on the environment, which is the ideal scenario. And also the syntax is quite nice. For example, when you want to export a function, so when I make a function public from a module, you use the export keyword. So it's kind of similar to the common JS approach. And also you can import functions from, or you can import a full module from another file and use the import keyword, which is like similar to what you do in Python. Also, you can, for example, you can export default, which is another nice feature of ES6. So you can set a default function that you're going to associate to a module. Other important thing is that now you can use classes. So it will look like more Java. And you can define a constructor using constructor. But this one is just a syntax sugar at the end of the day, because you still have the prototypal inheritance. So there is nothing really new. It's just nice because it helps new developers starting with JavaScript in understanding better the language and experienced developer to develop faster, I guess. And it's kind of nicer, I guess, to be able to use classes. Also, you'll be able to use inheritance similarly to how you do in Java. So you can use extends, and you can use the super keyword to refer to the superclass. So for example, this could be like a kind of two classes in ES6. But at the end of the day, all this code gets translated into this code, which is how you will write now two classes in JavaScript, which is still the prototypal inheritance. So as you can see here, in the subclass, you say cat.prototype equal object.create and the superclass.prototype. And for example, if we need to invoke the function of a superclass, that's what we do at the moment. So for example, animal.prototype.toString.call this, which is like really long and really cumbersome. So instead now you can just use super, which is really nice. So yeah, I mean, other thing to mention is that the reason why we still have the prototypal inheritance, I mean, which is nice, is because ES6 tried to be backward compatible. That was one of the main problems about ES4, that it was breaking things, whereas now with ES6, we try not to break things. And also, we've got template strings. So if you use the backtick character, now you can pass in, you can create templates. So you can, you can create, you can pass in variables inside these templates. And also you can have multi-line, finally in JavaScript. So not only in, for example, in Ruby, but now finally in JavaScript, you can write multi-line. Also, you've got API improvements. Just quickly, for example, on strings, we've got a few prototype methods that we usually are able to use, but for example, we leverage on libraries like underscore and Lodash to have them, but now they're built in the language, which is nice. Methods on number. So for example, is integer is not a number, it's finite. They're available on the number class instead of being available on the window, which makes more sense. Array methods. So we've got some static methods, new methods like from and of, and new prototype methods like entries, keys, and values. Let's look some example about those methods. So for example, now if you've got an array like object, like let's say a list of DOM nodes that you get from query selector all, you can convert this really easily into an array using the static method, the class method from, which is nice. And also you can use of to convert a list of arguments into an array. But also you can use, we have new prototype methods. Entries, for example. So using entries, you'll be able to get both the index and the value. And entries is generates an iterator again. And also the other two methods we saw before, so keys and values. Keys gets the indexes, and values gets the values. Values is kind of redundant, by the way, because if you use 4 of an array, you get the value, as I showed you before. Also, you get methods on the object. So, for example, you can have a set prototype of. So you can set the hidden prototype on an object. And also, or you can create mixins using a sign. Also, you can compare object using is. Really nice methods, especially set prototype of. In ES5, you get prototype of, but now in ES6, you can also set the prototype of. Also, you got math methods. I'm not sure if you will ever use it, like log or sin, cause, yeah, but it's nice to have. And last topic, but not last in importance, very cool feature is proxies. So with proxies, you can do meta programming in JavaScript, and it's really cool for logging or if you want to do some profiling. So the main thing about proxies is basically you listen on an object, on a target object, and you define some interceptors on it. Those interceptors are called technically traps. So let's look at an example. So given this object literal with the property num, say it's equal to 1. Now we can create this proxy which listens on that object and has got this interceptor called set. This interceptor, what it does is basically listen on whenever you set something on, like a property on an object, this function gets triggered. So when you do object.num equal, internally you call, the compiler call this set internal operation, and this set internal operation maps to this set trap, and this function is called. So when we do object.num equal to, this function is called, and the argument will be the target, which is the object. The property in this case is num, because it's the property we are assigning a value, and the value which is 2. And now, as you can see here, an example is that we can redefine the value of the property. So you can change the value of the property. So if I try to print out again object.num, I will get 3. So I can change the value of the property, which is open like a the door of different things you can do, like mocking, for example. This is another example of, for example, how this is an example of how you can create a defensive object. This is code from Nicholas Zacker's blog. It's basically a way of creating an object that if you ask for a property on this object and the property doesn't exist, you get an error instead of getting the undefined. Because at the moment, as you know, if you have a property that is not defined on an object and you ask for it, you'll get undefined, which is confusing. So as I said, so again, if you have an object with a property called name, for example, and I try to get the another property called last name, which doesn't exist on the initial object, what happens is that this trap, this interceptor will be called, because when I do object.lastName, there is the internal get method is called, so and is associated to this get trap. And then this trap is called, and then I'm inquiring about, is the last name property part of the object? It's not, so I'm calling a reference error. A further expansion of this is that you can also create typed typed objects. If you think about it, like you can define properties on an object, and then you can check against the initial type of those objects. So if I define the property as a string initially, and then I ask for the same property, I redefine the same property as a number, I can check that the type is the same. So if you define as a number, it's different, so you can throw an error. So like a bit of recap, what we saw today, fat arrow functions, scoping, distracting, and default values for parameters, REST parameters, generators, iteration, iterables, collections like sets, maps, weak maps, classes in ES6, templates, modules, some API improvements, new methods for an array, objects, and strings, and proxies. The last two slides. So pretty much they're not the only features that are in ES6. There are promises, which are really cool for managing asynchronously. You've got the better Unicode support. You've got optimized tail calls. So for recursion, you basically manage the stack in a better way, and symbols. And yeah, you can find here a few links for where to see, for example, where ES6 is used at the moment in the browser. And this is the link to the slides. Cool.
Thank you, Sebastiano. Unfortunately, we consumed all the time, and we don't have time for questions. Okay. So please send questions over application to Sebastiano or catch up him in the discussion corner. Thank you very much.
Yep. Or you can just, I'm just around, so if you want to ask me some questions, I'm around. Thanks.
Спасибо большое.